Thank you for joining today's webinar with Snowflake Computing, Infotrack and Matillion. My name is Joe Stedman and I'll be your host. And joining me today we have Alan Eldridge, who's the Director of Client Services over at Snowflake. We have Infotrack's Head of Innovation, Richard Morwood, and Ian Funnell, who is the Director of Solution Architecture here at Matillion. So in terms of structure for today's session, we're first going to hear from Alan, who's going to provide some detailed insight into some of the key advantages and features of the Snowflake data warehouse. We're then going to pass controls over to Richard, who's going to talk about how Infotrack have leveraged Snowflake and Matillion to build out a data warehouse. And then we're going to hand off to Ian, who's going to provide a quick demonstration of Matillion ETL for Snowflake and talk through some best practice examples. So the final part of today's session we have set aside for a Q&A. So I would encourage you to use the window provided and ask any questions you have from our three presenters. The aim is to have around 10 minutes at the end to go through these questions, so feel free to contribute as we go along. So that's it for me. Thanks again for joining, and without further ado, I'm pleased to hand over the controls to Alan from Snowflake. So over to you, Alan.
Great. Thank you, Joe. Pleasure to be here. My name is Alan Eldridge. I run the pre-sales team for Snowflake in the Asia-Pacific region. My intent today is to just give you a very brief overview of what Snowflake is. I've only got a short period of time, so I am only going to just cover off some slides, no demo from me today. So those of you who are unfamiliar with Snowflake, in simple terms, we are a cloud data warehouse. So we are a fully relational analytic engine running in the cloud. We are delivered as a software as a service. So you can sort of think of us as the Gmail of databases. You subscribe to our service. We provide you with an endpoint to connect to that service, and you then use drivers like ODBC, JDBC, Python, Spark, etc., to be able to connect in and use our service. The most important point on this slide here is really that middle point, that we are built for the cloud. Snowflake runs on a cloud stack. We run on Azure and we run on AWS today. And we run on top of those cloud stacks in the same way that a traditional database would run on top of an operating system. So we leverage the services that those cloud stacks provide to run our platform. Now, when we explain to people what we are, I guess the immediate reaction we often get is, why? Why would you create yet another database? And it's a good question. In its simplest response, we believe that the current platforms, they're just not working. So there are a bunch of limitations that our customers talk to us about, and they fall into these broad buckets. They can be related to complexity, so that could either be the complexity of the underlying infrastructure. It could be the complexity of the data preparation or data maintenance required to run on those platforms. We have a lot of customers who have challenges around scaling their environment. And I'm not just talking about a point-in-time scaling exercise here. As we all know, our businesses, our organizations are very dynamic. And so we need to be able to adapt our environment to support those changing demands over time. Oftentimes, these happen intraday or a couple of times a week, but it's not something that we're only talking about once every few months or once a year. So this concept of elasticity becomes really important, being able to flex our environments up and down to match these changes in business demand, and being able to not just have scalability in terms of creating a bigger cluster, but also having scalability in terms of matching throughput workload that's coming into the system, so changing the number of users who are accessing the system simultaneously and adapting to the number of queries that are being run, but also being able to support competing workloads and being able to isolate particular workloads into dedicated computing clusters so that when my data science users kick off a big task, they're not going to stomp all over my analytic users or my data loading process. This obviously then flows across into the cost model. It continues to surprise me that today in the cloud, we have organizations that are putting forward solutions that are based on a provisioned capacity model, whether that is a defined number of compute resources, whether that is based on reserved instances. But what customers are telling us they want is this ability to have a completely elastic cost model as well, and just pay for what you use in terms of storage and compute. The final point here is that increasingly we also need a platform that's not just going to handle the traditional structured data, but we also need to be able to deal with the semi-structured data that is now flowing into organizations, oftentimes being machine generated. So how does Snowflake address these challenges and make things easier? Well, it really boils down to our architecture. If you look at a traditional data storage environment, either on-prem or in the cloud, they tend to fall into one of these two patterns on the left, either a shared disk model, which is really what SQL Server and Oracle tend to look like, or a shared nothing, which is more along the lines of Hadoop-based solutions, traditional MPP databases like Redshift or Netezza or Vertica or Teradata. These environments were developed before the advent of the cloud, and so they're really designed to operate on provisioned hardware. The Snowflake architecture, in contrast, takes some of the best of both of those architectures, and so we have a single copy of the data as you would find inside a shared disk, but because we're now sitting on top of a cloud stack, we no longer need to concern ourselves with managing the IOPS to the underlying storage layer because the cloud fabric takes care of that for us. We can then have multiple independent compute clusters which are going to operate over the top of that single copy of the data, and these are just clusters of cloud virtual machines, whether that's EC2 or Azure virtual machines. So our architecture really has three layers. We have this centralized storage model, and for that we're just using low-cost blob storage that you would find in a cloud stack. In AWS, this is S3. In Azure, this is Azure blob storage. As we load the data into this layer, we automatically compress it, we automatically optimize it for querying, we encrypt it, we replicate it across multiple availability zones. Again, all of these things are things that you don't need to do. The architecture will take care of this automatically, which is quite different to many of the other solutions that you'll find out there. We then layer across the top of that our compute layer. So this is elastic. These things can flex up and down. They can be turned on and off because we're not storing data on the compute layer. There's a strong separation. And then this third layer is really the layer that you talk to. This is our services layer, and this is where the connectors like ODBC and JDBC talk to. This is where we manage our transactional control, our query optimization, and so on. So if we drill into this in just a little bit more detail, so we have a centralized storage model in here, and so the little disk icon in the center here really represents the physical storage inside Snowflake. On the left-hand side, what you'll see here is the global services layer, and this is where the logical structure exists, so the concept of a database or a table or a view. We are just a standard relational engine. We're a database, and so on one level we're really familiar, and all of those things that you would expect us to be able to do are delivered through that services layer. But the physical storage is highly scalable. As I said before, we're just using blob storage, so really we treat that S3 layer, if you will, just like a really big disk, and so we can scale our storage from megabytes to petabytes without needing to refactor the solution at any stage along the way. I've already mentioned that we will encrypt and manage the data as we load it in. One of the key points about Snowflake is this strong separation between storage and compute. So our compute layers are just clusters of EC2. We can have multiple of these clusters running simultaneously. Each one of these is isolated from the others. So a workload that's executing in one of these has no impact at all on the activity that's happening in these other clusters. And so what that means is that our concept of capacity planning becomes much more simplified, because it's simply, for a given workload, how much compute resource do I need for this right now? We use this T-shirt labeling as a shorthand for identifying the size of the cluster. So we can go from a single node all the way up to 128 nodes, from an extra small to a 4XL. So let's think about getting data into Snowflake. We are a database in the cloud, as I said, so typically it's a two-step process. You'll want to stage the data into the cloud first, and so in this case here, maybe loading a bunch of files for ingestion and putting them into a bucket where we're going to pull them from, and then I can just run some SQL commands to load those in. Now, obviously, in the real world, what we're probably going to do is leverage a tool like Matillion to be able to pull this data through, and this is really the story that we're here to tell today. We also have a streaming ingestion mechanism that allows us to pull data through if you have more of a continuously loading story. To get data out on the other side, either into a BI environment or perhaps into more of an advanced modeling kind of environment, we have our ODBC, JDBC drivers, we have drivers for Spark, we have drivers for Python, we have drivers for Go, and a number of other environments. So we can simply plug in and leverage that computing power of the underlying Snowflake layer. So that's all pretty much the same. The piece that really now starts to bring the cloud capability in is around this idea of instant elasticity. And there's really two directions that this elasticity flows. The first is vertically, as shown down here for the data science environment. So imagine I had a query that on a 2-node cluster takes 2 hours to run. Well, if I were to take that job and instead of running on a small, upsize my cluster to be an extra large, which is a 16-node, I increase the environment by a factor of 8. My runtime is going to come down, and usually it comes down linearly, assuming you've got enough to keep the nodes busy. So my 2-hour job is now going to run in 15 minutes. Because our costing model is based on a service second, it's a utility-based pricing model, this is still the same price, and this is something that's quite unusual for many people. So we can run jobs much more quickly by simply resizing up and down as we go. And we don't need to stop the compute cluster. We don't need to kick the users off. We can do this dynamically. The other kind of scalability that we need to talk about is horizontal scalability. So as we have more users flooding onto the system, it's going to start saturating. Well, Snowflake can detect that and dynamically spin up additional copies of a warehouse. So we can identify that there is queuing that's beginning to occur. We will spin up additional copies of this BI warehouse over here to be able to address that incoming need. This is something that is quite unique to Snowflake. Other platforms really don't have this multi-cluster capability, and so they really struggle with this kind of throughput scalability that I'm showing here. So in addition to just this isolation and scalability piece, there are a number of new things that allow us to reshape the way that you think about using an analytic data platform. So one of these is our native ability to store both structured and semi-structured data. As I mentioned before, data diversity is a real challenge for many people. And so we want to be able to bring not just traditional structured data in, but also semi-structured data like JSON, like XML that's being generated by these IoT and machine-generated mechanisms flowing through. And we store that natively, and we treat it exactly the same as structured data. We maintain the flexibility of schema, so we don't schema on ingest, but we store it in a way that allows it to be analytically available. We also have a mechanism called cloning that allows us to really change the way that you think about platforms like test dev. So rather than needing a dedicated environment that's always provisioned, that's always there, I only need to spin up a clone of my production for my development environment. This is a completely, it's a copy of my production environment, but we don't replicate the storage. It's really done at the metadata layer, so it happens very, very quickly and doesn't require additional storage costs to do. So I can make a replica of my production environment. I can spin up a dedicated warehouse that isolates the development workload away from production. And then as I make changes, I can simply just load those changes into the development environment over here. Then if I need to reset that process, I can simply drop the clone, and then I can rebuild the clone to reset my cycle. That allows us to iterate much more quickly than in a traditional architecture. And because we also now are leveraging this cloud storage layer, we have additional things that we can start to do with our data. We have a mechanism called continuous data protection. So again, challenging the way that you think about doing backups, for example. We don't need to do backups for protection against damage to the storage mechanism because our blob storage is highly resilient and highly available. But we're also tracking the changes that you make to data over time. And so at any point, I can run a query that says, select from a table as at a point in time. And that point in time can be anything up to 90 days ago. So it gives me effectively a zero RPO, zero RTO mechanism for approaching backups without needing to manage a manual daily backup process. And then the final piece that I just wanted to touch on in here is this concept of data sharing. So many organizations need to provide data to other organizations as a data provider, or we also act as a data consumer. And the way that you traditionally approach this problem today is by transferring files. I would export some data into a transfer format, and I would send it to somebody else. Because I'm shipping data to people, I'm constrained in the volume and granularity of data that I can share, and there's also a latency in how frequently I will update that. Because Snowflake is a multi-tenanted environment, if we have multiple organizations that are running inside Snowflake, I can create something called a data share. This is a governed, controlled mechanism that allows me to give live access to data in my database, in my environment. I can give access to other parties, and for them, it just appears as if that is a table inside their database. As I make changes to my local copy of that data, it is updated in real time. We believe that this is going to revolutionize the way that organizations share data. So what are customers doing with Snowflake? Well, if you think about a traditional modern data landscape where you have data warehouse, data marts, and so on, because we are an analytic database, clearly that's our sweet spot. We're taking those workloads. But because we have this ability to store semi-structured data, because our storage is blob storage and it's very low cost and it's very, very large, we increasingly see customers that are using Snowflake to adopt some of these data lake workloads. And then as we move away from an ELT, from an ETL to an ELT mechanism, again, this is something that Matillion is very, very good at, and we're seeing these pushdowns start to happen where we're leveraging the power of Snowflake to make these transformational changes. We're also, as I said, moving into this whole new area of data sharing, which is going to revolutionize the way that we interchange information between organizations. We have a lot of customers globally, over 1,500, and you'll recognize many of the logos that are on this particular screen here. I don't have time to dive into any specific customer stories, but this is obviously where Richard's going to come in to talk about their experiences here. So at that point, I would like to hand over to Richard, and he can talk about a real-world experience using both Snowflake and Matillion. Richard, over to you.
Thank you very much, Alan, for the introduction there. Hi, everybody. My name is Richard Morwood, and I run the innovation team here at Infotrack. When I joined the company about a year and a half ago, they said, let's start our big data journey right now. And so I started using a particular data vendor with Matillion. And Matillion was wonderful and amazing in our orchestration and transformation tool. Our other data provider, due to some technical things that we had to deal with, it started to turn into a bit of a rough seas for us as we started moving further into the line. So then recently we switched over to Snowflake. Snowflake and Matillion has proven to me to be the absolute winning combination, and it's been absolutely smooth sailing ever since. All right, so first off, who is Infotrack? Infotrack is a tech company servicing the legal, conveyancing, and accounting verticals. Now, as a conveyancer in New South Wales selling a property, you would need to do, on average, 16 searches against multiple authorities. Now, you could go to all of those 16 individual authorities and try to integrate everything and manage your email and expectations of delivery and integrate everything back into your practice management system, or you could come to Infotrack. Infotrack can connect you to all of the authorities across Australia, and we integrate everything directly back into your practice management system, giving you one single point of contact. Now, we offer 4,500 different services in Australia across searching across people, companies, and properties, and we also have offices in the UK, US, New Zealand, and across Australia. Now, this leads to us having quite a lot of data. And now the first time I heard of all those features that Snowflake just described, I admitted that I thought it just sounded like superficial marketing talk, and I was started to spin up a trial, and boy, was I wrong. It is everything that it says it is and more. Now, because of our old data provider, which had an integration with Matillion, we've been using Matillion for 1.5 years now, and it's been absolutely wonderful. So when we were looking for a new technology database provider, it had to have integration with Matillion, or I was just straight up not interested. So here's an example of what Infotrack can do. We don't just put you in touch with the service providers, with the authorities. We also give a bunch of value add to that data on top of it. So here on the left-hand side, we have a bunch of text, a complex document which has come back from ASIC, and it's of Infotrack's ASIC extract, and this is just part of it. Whereas over on the right-hand side, we have what Infotrack can do with that document. You run it through our reveal visualization tool. We'll extract all the entities out of it. We'll recognize what's a company, who's a person, what's an address, and we'll start to put everything together and paint a picture of how that company fits together. So you can see who the directors are, who the shareholders are, what their address is, how long they've been a director for, who is the global ultimate owner of that company, and Reveal also enables you to continue to do on-searching. So looking at Infotrack here, we have our ultimate parent company of Australian technology innovators. You could now, from this tool, click on that one and on-search the ASIC extract of that company. Now we'll do all of the same entity extraction, and we'll continue to build out this giant big graph of how everything fits together. Now, when they contacted me about 1.5 years, oh wow, close to 2 years now, they said, Richard, we want to build a database, an instantly searchable database of every single person in the world, and we want it to return all of their assets. So a few key things that stuck out to me from that description there was every person in the world and all of their assets. So dealing with billions and billions of rows, and I need to have everything be relational, and I'm going to need to be transforming that because it's going to be coming from its raw data where I need to do some entity extraction and parse data quite a lot and then relate it together. And it also needs to be super fast on the searching. As I was sitting there thinking, hey, I could probably pull that off. This is going to be quite an interesting job. How would I do it? They then said, now let's just focus on Australia first. And I started to wipe the sweat away from my brow. All right, so first things first, when we got started on that project was I thought we're going to need a wonderful orchestration tool and a transformation tool. Enter Matillion, solved all of my problems. And so we set up everything with Matillion, and as I was saying earlier, when we switched away from our old data provider to our new Snowflake provider, one of the key features that it needed to have was an integration with Matillion. So what is Matillion? It is a visual ELT tool which can help you with orchestrating what times jobs should start. It can connect up to a bunch of AWS services. We're a very AWS house here at Infotrack. And it can also write all of the SQL that you need to run against your database to transform things. And it also outputs data to other areas as well. So I will leave it to Ian, who will come up after me, to give an actual demo of Matillion. You'll see it in action, and I hope you love it as much as I do. But why we use it is that on the innovations team here, we're the company's R&D department. There's two things that I need to have in any piece of software. Is one, I need it to enable my team to move nice and fast. And the second one is I need something that has really fantastic support. So Matillion ticked off both the boxes in this one nice and easy. They have very quick service. They get back to us with any support queries that we have, and they treat us like absolute royalty. Not only do they come back with with the answers to our support questions, they also come up with Matillion files that they can send us and say, here's an example of what I'm trying to describe for you, and this is how you could recreate that scenario, and how this Matillion job that I've created, which is fully commented, documented, will answer that question for you. Then if we still have further questions, we go, look, it's just going to be so much easier if we could just speak on the phone to do this one. We're in Sydney, they're in the UK. That doesn't seem to be a problem for them because they still get up super early so they can be available at 6 a.m. UK time to be on a phone call with us so that we don't have to stay back from work. And they don't even ask us, would you mind staying back till 7 to make it easier for us? They just take all that and say, we'll get up at 6. We'll be available for you. That is wonderful. I really, really appreciate them for that. The other thing is that how easy it is to work with Matillion and get set up. We went to the Amazon Marketplace and we said we'd like to get Matillion. And it says, fair enough then, here you go, sir. There is now a new EC2 server that has all of your, that is Matillion, and you're ready to go. Being an EC2 server, that means it also has per hour billing. So as we if we're doing a particular job and then when that job is finished, we just turn Matillion off and we stop getting charged for it. There's no ginormous upfront cost for us, which is, I think, is really, really, really wonderful. So what's next? So Matillion has been quite wonderful for us. Let's switch over to Snowflake. And I'm not going to talk about the old data provider and problems up there. If you've got questions about that, please feel free to get in touch with me directly after this. I'm happy to answer all your questions. But Snowflake didn't just solve the one problem that we had, which was that my existing provider was rather expensive for our particular use case. They had everything else that Alan had just described. There was the absolute separation of storage from compute. Now, we used to have, I'm just going to say the name, we used to have 3 Redshift clusters set up for Vlore, and that, due to some technical limitations on the data that we had, we needed to have 3 distinct clusters, and that led to a data siloing for us, which was quite problematic because I did want to link some of that stuff together. Thankfully, with Snowflake and its true separation of storage and compute, we're able to create these different databases that can still remain independent of each other. Yet, with Snowflake, I can spin up a cluster and I can connect all of the different data together. I can create individually or I can join it all together, and that is really, really powerful for us. The other thing that has with that storage, separation of storage of compute, is that we can, the concurrency issues that we had have just disappeared, because if a cluster is starting to get overworked a little bit, we can just double the size and increase the concurrency. Or we can spin up another cluster and say, here's one cluster talking to the piece of data, and here's another cluster talking to the same piece of data, which works out really wonderful for us because we've got our marketing guys who want to query some data, we've got our CRM team who want to query some data, we've got our major accounts who want to query some data, we've got our own executive team who want to be querying some data. So these 4 different sources. And our development team who need to be interacting with that data at the same time. We can all use our own connection to speak to that single source of truth in the data store, which is wonderful. The great thing about that is, looking at point number 3 here, it gives us a resource usage breakdown. So we can see this cluster that is in use by major accounts has been running these queries and has been used this much. And it comes on, we can look at the billing system for it to see this is percentage of the bill that we should be recharging over to major accounts. This is the other one, the other part of the bill we should be sending over to our development team, and this is the other part of the bill that should be going to the marketing team. That's really, really wonderful. The point number 2 here, the instant cluster provisioning, is that you can write out all your query, you can write out your complex query take as long as you need to do that, and then you go, now it's time to run it. This part here really blew my mind, in that instant cluster provisioning, this was one of the main key points that I thought, there is no way that they have this. It's write the query, and as soon as you press execute the query, it goes, there's a new cluster for you, sir, and it executes the query, gives you back the results. Now, that spin-up time takes less than a second, like less than half a second. It's completely unnoticeable. Again, I'm going to say that word. It's just wonderful. It's really, really wonderful for us. It was wonderful, and it was fast. The other part is that the way that it turns off those clusters is it keeps it on and remains it on behind the scenes. And now, as soon as you stop using it for a period of time, I think I've got mine set to 5 minutes at the moment, it goes, and if you're not using me anymore, then no worries, I'm just going to go ahead and turn myself off, and I'll stop building you while I'm at that, which is just rather fantastic. When we have our production system running, and now we need to do some dev work on it, dev work onto a whole new database, we can type in the actual command. I love it. It's just clone database sales, and now it goes, no worries, by the time you think this is going to take me a bit of time, so I'll lock my computer, I'll get up and I'll go out the door to go get a coffee, and it'll be done by the time I get back. Actually, by the time you've stood up from your desk and made it to the door of the office, your database, Snowflake is already telling you, I am done with your cloning of the database, you are good to get back to work now. So there is no big giant delay. I remember when we had to do that before with our old system, it was let's create a snapshot of it and then recreate a whole new cluster. It would take up to 24 hours to get us a dev environment, whereas now we can snap our fingers and have it within a few seconds. That is wonderful. The other thing that we needed is that it needed to go on with our data visualization tool, which we use Tableau here at Infotrack. And Snowflake just had a connector that just started working with it straight away. So we didn't have to change much. We just had to take our existing queries, put them into Snowflake. There was no schema changes. There was no data syntax changes we had to do. It was just direct copy paste, and now we're up and running again on our new environment. Very, very, very impressive. All right, so let's take a look at that service I was talking about earlier, the asset search. So here is what the whole architecture of the asset search looks like. We can see down at the bottom we've got the development team using all the AWS code pipeline and code deploy and code build services. In the middle on the right-hand side, we've got the VPC where the Lambdas run, where the load balancer runs, and the ECS container runs. And now over on the left-hand side, we've got the data flow. I'm going to focus the next slide on just the data flow for this particular presentation. So now what does it look like in practice here? We have all of our different data sources being from multiple authorities across Australia. We take all of those search results and we stick them into S3 as JSON. Now, there's a bit of things that we need to do to that data before we can bring it into Snowflake. So we run it through Spark to do a bit of transformations. Now we pull that raw data into Snowflake into the staging tables. At this point, we run Matillion jobs. Matillion says, hey, Snowflake, you've got that data in staging. I'd like you to run all of these SQL queries against it and output the results into the final tables on the final databases. So Matillion orchestrates that, tells it what time to run, what transformations it should be doing, what SQL it should be running, and it pushes all of the power. It says, Snowflake, you're very fast. You go and execute these commands, and I will orchestrate everything to run together. Now, as soon as Snowflake says, I am done with that part there, great, Matillion knows I will now do the next phase of the orchestration job. In our case, we don't want our Snowflake database to be a public-facing thing, so we have an API layer which covers off from the back end. In this case, we use Elasticsearch for our instantaneous searching, and we also push a whole bunch of results over to Amazon Aurora, which is where we store the front-end data of the asset search. Now, for our switch from Redshift to Snowflake, we didn't have to change anything. From this whole workflow here, all of our data pipelines and our ETL jobs remained exactly the same. We just had to take out one database and put in Snowflake, and hey presto, we were done. So with the combination of Snowflake and Matillion, Infotrack has indeed found that we've now got absolute smooth sailing in our data waters. And at this point, thank you very much. I'll be here for question time at the end. If you have anything, or feel free to reach out to me directly. I'm now going to pass over to Matillion to take over here and give us a demo of Matillion. Thank you very much.
So, Richard, thanks very much for running through that. Really interesting to hear around your architecture and the sort of key differences that implementing Snowflake have made to the overall business and your efficiency in terms of your data warehouse build. Some really interesting stuff. So I'm going to shortly pass over to Ian Funnell, who heads up our solution architecture team, and Ian's going to take us through a live demo of Matillion, show us some of the key features specific to the Snowflake product, and talk around some sort of best practices as well. Just wanted to sort of provide a little bit of background and orientation around Matillion. So we're a UK-based company, but we provide software worldwide. We have over 450 customers across 40 different countries. Matillion is a cloud-native data integration tool. It's been built from the ground up to be cloud-first. It utilizes a push-down ELT architecture, so very different from traditional ETL tools. You no longer need to maintain, run, and scale a dedicated ETL server, as what we're doing is we're actually taking that data, we're extracting it from source, loading it onto the data warehouse, in this instance Snowflake, and then we're using that compute available in the Snowflake data warehouse to execute the transformations of the data in situ, which is giving a massive boost of performance in terms of how quickly you're able to transform your data. But of course, it means that you're then reducing your overheads and the footprint you have in terms of any architecture and infrastructure. And of course, it's all very scalable and also very secure, because Matillion is really just running on an EC2 instance, which sits inside the customer's existing VPC. So it's very much your software and very secure from that perspective. We don't see or process any of the data, which is great. And as you'll see through the demo shortly with Ian, Matillion is a full browser-based tool. It's a visual drag-and-drop development environment, allowing you to visualize your ETL flows as you build them and get real-time feedback from the underlying database or data warehouse cluster as you build out your jobs, which is really useful. It's exclusive to the AWS marketplace, so you can go there, search for Matillion. You can then launch the product in around 5 minutes, as I say, running as EC2, and all the billing is handled directly via AWS, and that's paid by the hour. And there's an initial 14-day free trial available, as well as a 72-hour test drive, so you can try out the product in a sandbox environment without having to connect it to any of your existing data warehouses. So that's it. You'll see we've got a number of customers there, some great examples of the types of customers that we work with. So I'm going to pass over to Ian, who's going to talk through some of the best practices and provide a quick demo. So over to you, Ian.
Excellent. Thank you, Joe. A couple of important points to mention very first of all. This is what you would see very first time you logged into Matillion if you started it up from the marketplace. And it is a completely web native tool. So I'm accessing this simply through a web browser. And as Richard mentioned, you can start a new instance of Matillion within about 5 minutes from the AWS marketplace page, and you own that instance. You're free to start and stop it on demand according to when you need it. Coming back to the point that Alan made at the beginning, it's very much an ELT tool, despite the fact, ironically, that we're actually named ETL. Don't be deceived by that, and don't also be deceived by the way it looks, because it really is an ELT tool, meaning that it takes advantage of Snowflake to do data transformations. So a quick look at the interface. You begin by organizing your work into a folder structure, and I've got a few folders set up here already. And the things down at the leaf node type part of the interface here, these are the jobs which do the actual data ingestion and the data transformations. Now you'll see visually there's these blue colored ones which I've bracketed under the banner of orchestration, and these green ones which I've put under the transformation folder. And they really do, there is a strong distinction between these two kinds of jobs that you can build. And it really comes right to the heart of the definition of Matillion being ELT. So the green transformation jobs essentially build SQL statements. So they get Snowflake to work by building SQL and pushing down that SQL onto Snowflake. And I'll show you what that looks like in a few minutes' time. The blue orchestration jobs, they really do everything else that the tool can do. So two main functions. Number one, data capture and ingestion into Snowflake from lots of different sources. And number two, they fulfill a command and control function as well. So I'm going to double click this one to open it and just zoom in a little bit and talk you through what's going on here. So this graph type structure, obviously we start here at the starting point, and you can follow the arrows to see what order things will get executed. And this is what Richard was meaning by Matillion orchestrating data flows and running things in the right order, and error handling and reporting and instrumentation, that kind of things. To begin with, the very first thing that we do here is change the warehouse size. And this is taking advantage of all of that elasticity that Alan was describing initially. So if I click onto the component here, you can see the properties window. And actually, I'm going to go into this one just to show you. It's all dialogue driven when you're using Matillion. So you can set your properties in this way, but actually what it really does at runtime is create a SQL statement, and that's not a particularly complicated one. It just alters the warehouse size. So what I'm doing here is setting my warehouse size to large. So I've got a lot of compute power to do my perhaps this is my nightly batch run. This is my data ingestion, this is my transformation. And then when it's finished, I'll do the resizing back down to a small size so that can handle whatever comes next. So this is one way that you can optimize your consumption of resources and optimize your costing as you're using Snowflake and Matillion. So what's going on in here is we have some create table statements, which simply create empty tables ready to accept some data. Typically, this is it's known as a staging area. You might be one of multiple logical data tiers in your data architecture. And again, these just generate, there's a table name, there's some column names in here, and these generate SQL statements as well. It's basically a create table statement. A large proportion of the time that you'll spend in orchestration jobs will be normally developing these EL or extract and load components. And I've got a few examples here of various different ones, just to give you a feel for the kind of things which are available. This is an S3 load or a blob storage load. It would be if we were on Azure here. And it simply takes data from a blob storage bucket named here with some file patterns into that table. It's a custom format that I'm using here, CSV, and I've set a bunch of the properties of the CSV file there. This will generate a big copy command, which is Snowflake's bulk loader, and that will cause Snowflake to bulk load the data out of S3. Another very widely used one is our RDS query, which is essentially a relational database query. This is querying a MySQL database. So you've got a JDBC endpoint, you've got username and password credentials, and you've got a select statement. So this is actually a multi-pass component. It will run the select statement on the MySQL data source, and it will do a bulk load in a second phase, very similar to the copy command here. And it's in this way that you can effectively federate out your connection from Snowflake out to relational databases. The last one I have on my screen, just by way of example, is a query on Salesforce. And this is going to at the contact feed data source in Salesforce. I'm authenticated as our Matillion account on here, and I'm fetching some columns from that table into a new table in Snowflake. So there are 50 or 60 different data ingestion components that we have, and I won't bore you by listing them all here, but they're all on our website. You might want to have a browse through and perhaps check that the ones you're interested in are supported. We have a synchronization component that will just wait for all of these three things that have been running in parallel to finish before handing over to a data transformation. Now, I'm going to double click into here and I'll show you what push down ELT really looks like inside Matillion. So again, we have a kind of graph type structure. It looks superficially pretty similar to the job that I had on the screen a moment ago, but as I said earlier, don't be deceived by that. This is doing something really very different. We are looking at two of the tables which were loaded in the previous job. This one came from S3 files. This one came from an RDS database. And because we're now looking at database tables inside Snowflake, we can do some things like very simply get a row count from the table. I've got 123 million rows in there, and we can get a top 50 rows out of here. Full advantage of Snowflake's power and scalability here. And that's just a select statement, by the way, that gets pushed down. I have a filter and a horizontal filter. For those of you who know SQL, you'll know that this will generate a where clause, but you don't actually need to even know that much about SQL. You can simply fill in a dialog like this and put in your values for the filter like that. And I can do a row count like here. Hopefully it's less than 123 million. Yeah, that's taken about half of the rows out of there. Let me show you some some kind of live demo here. I'll do a quick aggregation, a quick bit of data profiling on that source data. And if you remember, I had a year column in there. So I'm going to aggregate up by year, and I will get a count by year out of here. So fairly straightforward. Again, if you know SQL, you will know that this is going to do some kind of a group by in the background. And I'll check, first of all, the level of aggregation. Yep, I'm going down from 120 million down to 22 rows. All of these are live queries, by the way. And I'll just sort by year, and I can see my results grouped up by year. I would love to claim that it's Matillion that's able to aggregate 120 million rows of data that fast, but it actually isn't. It's Snowflake that's doing the heavy lifting here. Matillion is simply pushing SQL down for execution. We can actually see the generated SQL right here, and this is in fact do anything really that you can construct in SQL, filters, calculations, deduplication, joining two different data feeds here, and in this case, creating a new table, a new denormalized table for use downstream. You might be exporting that, you might be sharing that with another, with your own customers, or you might export that, for example, out to another database for consumption downstream. And this is actually one SQL statement which is generated. That's what it looks like, and that's what will get sent to Snowflake for execution. I'm going to show you one more thing to bring to life some of the things that Alan was mentioning at the beginning about how semi-structured data is handled in this kind of world. So what I have here is another transformation job, which takes some data from source. And I'll just show you the schema here, first of all. This is a single variant column in Snowflake, and that allows you to solve the problem of having to define your schema up front when you're ingesting semi-structured data like the JSON files that I have here. And it also enables you to work with that data, so bring it out relationally, and enables you to really easily visualize it. To show you what I mean, I'll do a quick row count on this table. There should be about 1,000 rows in there. And every single one of these is quite a complex JSON document. If I could show you it on my screen, it would be literally thousands of lines long with an embedded array in there. And it's really quite difficult to visualize or to work with in that structure. But one of Snowflake's unique features is the flatten variant clause that it has, which enables you to work with semi-structured data in SQL. So I've told it, using this dialog, to flatten out out of content the array called features, and from there bring out some of the nested structure into there, and some of them are nested multiple levels deep. So this is a bunch of seismic data that's pretty raw IoT type data that's been captured from seismic sensors. But once I've passed it through this flattened variant, I should hopefully, number one, see a whole lot more data. Yeah, I've got 162,000 rows now. And also, yeah, there we go, a quick data sample, top 50 out of here. It's been nicely relationalized. So I can see primary keys, I can see dates and times, latitudes and longitudes, and all of those kind of things that would enable me to work with that data and blend it in with other data sources to do my data integration. So that, of course, a typical example of that is a deduplication. And I have another here, merge. This is a merge statement, which takes that data and stores it permanently into a table which I can use. So I'll leave you with showing you the SQL here. This is generated SQL, and in here somewhere is there's the lateral flatten, which was done by the flatten variant here, and we've got a deduplicator, which is this row number syntax here. So all of this gets executed very quickly by Snowflake, and it's created by configuring these components in this way. So that's a whirlwind tour of what Matillion looks like when you're actually using it. I'm going to pause at this point and say thanks for watching the demo, and I'll hand back to Joe for the Q&A. So if you haven't done so already, please feel free to put Q&A to use the Q&A button.
Excellent, Ian. Thank you very much for running through that demonstration. Some really useful things there in terms of sort of working with both Matillion and Snowflake. Before we get started on the Q&A, just wanted to talk a little bit about how to engage. As I mentioned earlier, with Matillion, it's available directly from the AWS marketplace, so you can launch a copy of the software from there in under 5 minutes. There's a 14-day free trial, and then by the hour billing. We have a full team of solution architects to help support any POCs or evaluations, developments of MVPs. We also have a support portal and tutorials and sort of tips and tricks are available on our YouTube channel. So that's the best way to engage from a Matillion perspective. I thought, Alan, before we start with the Q&A, it'd be great to just understand for some of the people on the call really how they would engage with Snowflake. So if they wanted to start a Snowflake cluster, how they would go about doing that.
Yeah, absolutely. So very similar to Matillion, we have a free trial available on our website. Obviously, being a software as a service, there's nothing that you need to deploy or provision. It's simply a matter of going to our website, filling out the application form. We'll provide the first $400 of utilization for you to kick the tires and see if it does what you need it to do. Excuse me. So in order to get kick-started with the tool, snowflake.com is our website, and then you can fire up a what we call a self-service evaluation. You can continue that evaluation account forward. So if you decide that you do want to continue using Snowflake, transitions across to a pay-as-you-go model, and you can continue to use that account for as long as you like. We also have a sales team around the world. We have staff, obviously, here across the Asia-Pacific region, in Sydney and Melbourne and Singapore. So more than welcome to reach out to us. We'd love to speak to you about how you could use Snowflake to solve your problems.
Oh, fantastic, Alan. That's excellent. And that's really interesting because actually it allows the customer there to undertake a POC using Snowflake, using Matillion at no cost whatsoever. So you've got those $400 of credits there for the Snowflake usage, the 14 days usage on Matillion. We can provide AWS credits to help if you need to extend that. But what that means is you can build out that POC at no cost, but with obviously the great returns that you'd expect to see. So that's really good. So we've got a few questions come through now. So we're gonna pick on some of those. So the first one is, can Matillion provide a metadata-driven ETL framework with predefined patterns, e.g. type 1 DIMs, type 6 DIMs, transactional facts, snapshots, etc.? So that's the first one. Ian, are you okay just to confirm that for us?
Yeah, certainly, no problem. The tool certainly can do that. What we have is a way to build shared jobs and parameterizable jobs for basically anything that you need, and dimension maintenance like that would be a classic example. So we have quite a powerful variable subsystem with two-dimensional and ordinary scalar variables, which you can use to build that kind of thing. Absolutely, yes.
Great. Okay. Good. Alan, there's a question for you here on Snowflake. So in one of the slides, you showed the EDW and data marts. Are these data marts physical? Is the data persisted in this layer, or is it just a virtual layer performing reads from the EDW?
So the logical constructs that we're referring to here. So in Snowflake, you have the concept of an account. That's kind of like the top level object. So, customer A would have an account. Within that, they're then able to create multiple databases. And some of the terminology from a Snowflake perspective takes a little bit of relearning. So we talk about databases. From that front, we really just refer to the storage of the data. Here it's just simply a logical partitioning of the data. We don't require you to adopt any particular data modeling technique. If you want to use a star schema, or if you want to use normalized or denormalized, if you prefer data vault, entirely up to you. There's no specific data model that's required to use the Snowflake architecture. So going back to the diagram that I spoke about before, the data warehouse and the data marts would conceptually just be different logical databases within the one account, and you could use a tool like Matillion to then drive the data transformation pipelines between those logical environments. And you could then potentially even just have excuse me, as we saw the staging area, land the data into the staging area, set of transformation jobs running from there, populating out into the EDW schema, and then either directly or indirectly then feeding through into the various data marts. The thing that I will point out here is, again, that strong separation between storage and compute. So the terminology for us is database, and that is the storage piece. And then we have the warehouse, which is really just the compute cluster that sits over the top. I can have a single database used by multiple warehouses, and I can have multiple, I can have a single warehouse accessing multiple databases. It's a many-to-many relationship between these objects.
Great, thanks, Alan. So just one more question there for you. You mentioned earlier around the ability to share data using Snowflake. And the question was, are you able to share that data externally, or does it need to be with another Snowflake user?
It would need to be another Snowflake account. So let's say I am a data producer and I have a bunch of data that I want to share with another agency. They would need a Snowflake account. Now, there are two ways that you can approach this. One is that they might have their own existing relationship with Snowflake. They'd have their own Snowflake account, and then they are paying for their own storage and compute at that point. If I share data with somebody who already has their own Snowflake account, I'm going to be paying for the storage because the data is inside my account, but any queries that they run, they would pay for the compute. If you want to share data with an agency that does not have a Snowflake account, we have the concept of something called a reader account. So that means that as the data provider, not only do I provide them the data, but I will provide them a managed account and a set of credentials that they can then log in to view that data with. Under this model, I could potentially deliver this entirely as a value-add service. So I would be paying for the storage and the compute, and as such, I then have governance and control over what the other party is doing inside that account with the data that I'm making available to them.
Right. Excellent. Very, very powerful feature. Great. So, look, we're at the top of the hour. If we've not answered any questions, then we'll pick those up and we'll email you directly with an answer. So I'd just like to take the opportunity to thank all of our presenters today. Thanks everyone for joining on to the webinar, and we'll ensure that a copy of this recording is made available within the next 24 to 48 hours. So thanks very much, Alan, Richard, Ian, and thanks everybody for joining on to today's webinar. And have a good day.